Welcome to Sprague Insanity. If you accidentally came across this YouTube video because you're searching for solutions on how to create snow in your environment, or maybe do some mesh manipulation, or how to handle the terrain, welcome. First of all, what this video covers is more of an overview of what I did to get snow into my environment. It is not. This is not a step-by-step, in detail tutorial showing how to code each line and going through it. Instead, what I want to do is just provide you access to the code I wrote. I have published it out in Github. I'll have the link in the description below that you can reference and go out and find the code, as well as a PDF document that explains it at a high level. Purpose of this video is basically just to give you a feel for what problem was I trying to solve and how did I go about solving it. Now, here's a couple caveats. One, I'm a newbie with this software. I'm a novice that has just learned Unity in the last 2 months. Learned a lot, still have a lot to learn, so I'm not a game developer guru by any stretch of the imagination. So take that with a grain of salt when you see my code. It's rough around the edges. Probably not the prettiest thing you've ever seen. But I did want to share this because I found this experience to be quite fun, especially in the Unity community. Is pretty cool. A lot of expertise given freely out there, a lot of help, as well as code samples and solutions that people have shared that they put a lot of time and effort into, and it's made the learning experience a lot of fun and worthwhile. So I figured, hey, I need to pay it forward. I've leveraged a lot of these YouTube videos, tutorials, blogs, forums to learn, and so I want to consolidate that and kind of show or give back. And hopefully somebody gets some value out of this. If you get value from it, from my code, because you want to make snow and you like it, fantastic. If you think it's crap and doesn't do anything, maybe you get some value out of some of the techniques that I use to implement the snow, which is dealing with mesh extraction, finding a piece of the mesh from a given game object, in this case identified as top or up. And the other thing, mesh extrusion, which is extruding that mesh, making it into a solid object by building faces and triangles and vertices. And the other thing I implemented was subdivision, where I could take that mesh if it's not fine enough granular detail and add more detail, more triangles and vertices, so that I could feed it into another routine I created, which is the smoothness application, which smooths out the right angles and sharp edges. So you may get value from seeing how I implemented those, taking, of course, examples and work done by others from the community. Or at the very least, maybe you get value, if you're not getting value from the code, maybe from my documentation I put together from my learning experience. In my document out in GitHub, in the appendix, I created a reference section, and it's all the videos I found, the blogs, and various other inputs that I found during my research that you may find as a newbie trying to learn this stuff like I am, might find valuable. I know Google search is fantastic, but sometimes it's just really hard to find that one piece of information that you're looking for, or the solution or answer. So that might help as well. So anyways, all that being said, what was the problem I was trying to solve? I thought it would be cool to be able to take my current environment that you're seeing here, a very simplistic environment. It's got a few game objects thrown in. It's got terrain with the speed trees, conifer trees. It's got flags waving. It's got the grass and flowers from the paint details of terrain tools. And I thought, wouldn't it be cool if I could just make this look snow-covered? And by turning on a switch, and then it's all snow-covered winter wonderland, and then turn off the switch, and I'm back to my original terrain, without having to create snow-specific objects snow-specific terrain, or anything of that nature. Reuse the current terrain without clobbering that terrain. And the other thing I wanted is thick snow. I wanted to be able to show what the snow would look like from a thickness perspective to give it a little bit of depth and feel to it. So when I started off this endeavor, I initially started with graph shaders. And the graph shaders do a fantastic job, and I'll show you what those look like in this environment. So if I go over here and turn on my demo, and show what the shader would look like when it's implemented. And this is where I started originally. Bear with me as it loads up. It does a fairly decent job. Now, I don't have the same working 100%. I just kind of threw it in here, but it's more from a demonstration perspective of why I wanted more than just a graph shader. If you notice on my objects here, like on my pillar, does a good job, and on the fence, does a good job of identifying what is top or up, and it gives that nice snow effect. Now, the only thing, the downside of it is there's no depth to it. It looks like it's painted on, but still a pretty neat effect, right? Same with the terrain. Good effect, gives you that snow-covered look, but problem is, geez, you know, I really want thick snow. I want a winter wonderland, and this looks like it just snowed in spring. Grass is popping up through the terrain here, so of course a snow shader doesn't address that those painted details. Same with the trees. Trees have no snow covered on them. So I thought, geez, you know, this is a good start, but I really would like the grass to disappear. I really would like some thickness to the snow, and that's where I started going down the rabbit hole of trying to figure out how to do this. So going back, I finally created, by a lot of research, what I call my create snow procedural script that coordinates everything. And here's what it looks like. So let me get out of here, turn off the shader. Go to my create snow, turn that on. And right now I just got this up as a demo script for this video. Takes a while to fire up here at the beginning because what it's doing is it's going out to all the objects that I have identified and creating snow for it. So here we go. Now, if you look at this, I've created this with minor extrusion, saying find up, take that mesh, extrude it, make it into a mesh object, color it like snow, and have it sit on top of the original object that I created the mesh from. So you can see it gives a little bit more depth to the snow look on these surfaces. You notice the other thing that's happening here is my snow in my environment is thick. It covers everything. There is no grass and flowers poking through. And lastly, notice the trees. All the trees have had the snow shader effect applied to make it look like it snowed on all the trees. So how did I go about doing this? Well, first, what this job will do, or this procedure does, is it goes out to the terrain. He applies the shader I showed earlier so that the far off effect, you still see snow-covered mountains and hills. And then it goes into the terrain details, makes a clone copy of the existing terrain, and he zeroes out the details within a certain area of where I want them to disappear. So basically it erases the flowers and the grass from the paint details and the terrain tools. But this is all done in memory, so it's non-destructive. So that's pretty cool. And then the other thing I wanted is depth to this snow. So I create a mesh that mirrors the terrain details, which is the height map. And so the mesh folds right on top and contours to the existing terrain. And then I just throw a snow color on top of it, and it gives this thick look effect. Now, what this doesn't do right now is as I'm walking through it, it doesn't deform the snow. And there's other great videos out there by World of Zero and Brackeys that shows how to do this. I haven't implemented that right now, but from what I wanted to accomplish initially, this looks pretty good. The part of this that you're not seeing is the configuration of the snow is based on a mesh that you define the start location in the world and give it a size, and it will build out that mesh plane for that certain size. I apply the shader, the snow shader, to the conifer trees material, and that is destructive. That is a permanent change to the material. So I also set it back to the original material when you exit the game, so that you don't end up with snow cover during the summer. What else can I say about this? It only goes through every object and creates the snow top. So that's basically it, what my routine does. Pretty straightforward. Let me show you a few details of how this works. There's two configuration files that you would find out in GitHub that I have for this demo. The first one, and this is under the assets folder, the root level assets folder of your project when you install it. But there's this UI snow option settings JSON file that has a configuration for turn on the snow, the start position of the new terrain mesh. So you give it the XYZ coordinates in world space, and then you tell it how wide and deep do you want this mesh? How big do you want it to cover all the ground area with this mesh and make it look like snow? This controls the shader of how much snow to apply to the rest of the terrain that is not covered by the mesh. And this controls the amount of snow on the speed trees. It reads in this very important file right here, which I'll touch on in a minute, but this basically lists all the objects, game objects I want to apply snow to. And I'll get to why I had to do that in a minute. Here's the shader I'm using, and the shader that also gets applied to the speed trees. And then here's the default shader that exists on the given speed trees before I made any changes. I set that back. Now, for any reason, let's say that if the game were to crash or whatever, and you go back into your terrain and you're in your regular terrain mode, and your trees look like they're covered with snow. In other words, it still has a snow shader applied. You could always just rerun this and have it reset to the original shader. Now, where you find this original data, this particular solution assumes in the environment that you have installed the standard assets, which is, I believe that's part of the terrain tools. But the standard assets under it for the speed trees, you see environment, speed tree, you got the broadleaf tree information, and you got the conifer tree information. And under that folder, you'll see the different LUDs. And you'll notice right now as I'm running this, I have my shader applied. So before running this, if you are to take my code and run it, make sure you have this installed. If you're using the speed trees, go down and see what the original material is on each one of these. And it's probably speed tree 7 or speed tree 8. And then make sure you configure this file with that so I can reset it back. That's the only permanent, what I would call destructive change that this routine does. Everything else is done in memory. Nothing else in the terrain is impacted. Nothing on your original objects is impacted. And the way to see that is, as this game's running, you see I have a version of the terrain that's called snow, a version of all my individual game objects that make up the overall parent object for Arch. Same with the fences, same with the park benches. Now, let's get back to how does it know what objects, game objects, to apply snow to. My original intent was to create automatic recognition of every game object and just apply snow. But I ran into troubles. There's some objects that don't play well because they have pivot points that are misaligned to the actual object, causing problems finding the mesh, thus finding top, thus rendering the snow. In addition, some objects are very complex, and if you make the angle too big on them, it just picks up weird pieces of the mesh, and then when it renders the snow, it just does not look quite right. So you have to play with the angle on some given objects. So I ended up having to have a JSON file that has all the objects listed that I want snow rendered on with its individual configurations or options. Pain in the butt, yeah, on the initial setup, and yeah, it's a pain in the butt when you add objects or take objects away. You have to maintain this file. But, you know, out of the gate, starting off, I think it's a good jumping off point to at least get it to work in my environment. So let's take a look at this snow objects file. All it is an array list in JSON format of every game object with its options. And the options you provide are the high-level name and its part name. Now, for simple objects like adding a cube or a sphere or some other objects, sometimes you don't have a hierarchy. Sometimes it's just the name of the object and the hierarchy, and that's it. That's the only mesh that gets rendered. In that case, you'll put the same name in both of them. But this is a way to find uniqueness, especially when you have objects like fences that I replicated. So I took this from the flooded, I can't remember the name of the asset, flooded something. It's in the documentation. But I added the structured fence and then just duplicated it. And within the hierarchy, of course, it creates with 1, 2 to keep them unique. But you notice it has these LUDs underneath it for the actual meshes. And there's many of them under each one. I only need to mesh from one of them in order to find the top of it and render the snow. So it gave me good control over, I just want this mesh under this complex object. And going back here, let me show you what that looks like in the real world. So here's the meshes I'm talking about. The fences that I added. Go over the scene, like here, there's that fence right there. There's this one right here. But you notice under each one it has multiple meshes set up. So then I just choose one of them, and that's what I end up rendering from. So that's what I configure into this objects file. Some of these parameters that you can play with, angle, extract angle. This is going from, for example, if you're looking for up, or vector 3 up, starting at 0 degrees, fanning out by 70 degrees, I want to find all those vertices. And I want to pull the mesh, or the vertices for that mesh, and render it as snow-covered objects. 70 is fairly large, but that's what I found worked with the fence to get the very top, where it has a severe angle on each one of the fence posts. What direction am I looking? In this case, vector 3 up. So these represent the direction you're looking to pull the mesh. And this would correspond to like vector 3 forward, back, up, down, left, right. I haven't tested the other directions. It should work, but I've been mainly concentrating on up or finding the top of objects. How big do I make this new snow object? And so you do an extrusion. You can see these are fairly small, 0.05, not very big. I'll show you in a minute what it looks like when I do the ridiculous and build them big, and what it looks like in the environment. How many subdivisions do you want to make a pass at? Max 6, but basically every pass through it will add triangles inside of a triangle. So in other words, you're exploding from 1 triangle to 4. So it's a 4-to-1 ratio. And then what you're doing is you're splitting that triangle vertices, adding new vertices on each side of the existing triangle. So this gives you a finer detailed mesh. such that maybe you could do more work in your smoothness. And smoothness has a number of passes as well, and it will try to do a average of the neighboring vertices around a vertice, do an average, and move that vertice inward by that average. And then the smoothness factor itself, I just added this for giggles. I wanted a way to see if I wanted to play around and override how far the smoothness moved in. A 1 factor says use the algorithm as is. Anything less than 1 will lessen the movement. Anything greater than 1 will push it outwards and make it look kind of goofy, but it's something I was playing with to see if I can introduce noise and some other things. The adjust pivot, this is important here along with the debug vertex ray. I had an issue with one of the particular game objects, like this one. If you look at it, notice that his pivot point is way over here. And when I tried to run the up, he's fanning out this way, and he's not finding any up because his pivot point's so far away. So this is a way to adjust badly formed or objects that do not conform to normals. And it logically, in memory, moves that pivot point up under here, and then his up will start to work and he'll find the top. And I had to do that through the override of where to adjust the pivot point. So keep that in mind if you have a problem. So if you were to implement this and you're running it and you're looking at the object and going, there's no snow on top, and there should be, first place to look is at this. One way to test it is you can turn this to true. If you turn that to true in the edit mode when you run the game, it will send the debug rays to every vertices it finds or fan out. And you can see exactly what direction he's going to find your mesh. And the last one is whether you want this to be active with snow or inactive. Set it to false if you want this to be ignored. So that's pretty much what this does, and I had to set up for each one of my objects. Kind of a pain, I agree, but hey, you know, it's a compromise I had to make in order to provide some control. And this is sort of a beta release 0, if you will, release of what I've done. Now let me show you what happens when I do something really ridiculous and set it up to be big. So really set the extrude sizes to be large to give you large snow. So I'll save this and restart the game. By the way, this is only set up to run one time. It is not or on off. And I do have a UI I've cobbled together that I could do this during gameplay, but I don't have it here for demo. Okay, this is what it looks like when I set the snow up really large. You see how thick these things get? It gives you a lot more depth to the snow, almost to the comical size, right? And it only impacts the objects. Now, the other thing I want to show you is down here for what smoothness looks like with division versus no smoothness. So the two benches to the sides I did not smooth or subdivide. The one in the middle I did. So you can see it gives more rounded edges and sort of a more bumpier look to it. Same with this snow on top of the rotund here, or the roundabout. So that's it for the snow coverage. And then, you know, of course, when you shutter down, you're back to your regular terrain. The grass is back, the flowers are back, the trees are back, everything's back. The objects are as they always were. And it's a way that you could just leverage your same terrain environment and do whatever with it. Get creative with it. So I hope this provides some value. Again, all this code is going to be out there in GitHub in the description. There's a PDF document that gives a high-level explanation of the code, as well as the reference section I mentioned earlier that all the all the research I did with the links to the YouTube videos, blogs, etc., touching on various topics that I came across as I've been learning this over the past 2 months. So if you tripped over this video, hopefully I didn't bore the tears out of you. I hope you find some value. Oh, and if you want to stick around for a little bit, let me show you the debug method here. So let me go back in. Go back to snow objects. Ridge. And I'm going to go down to my arch, pillar left, and I'm going to set this to true, the debug, just to show you what it looks like. I'm going to fire this up. And you see how long it takes to go through with all the objects. You can imagine you have a ton of objects in this environment. It would take longer. So now let me go back into the editor, and this is the raise I was telling you about right here. So you can see right now the way I have it configured, that when I define up at a, I think it's 35-degree angle or 40-degree angle, these are everything, all the vertices he's finding with these rays. So he's finding them, and of course the original vertices right here, right? But then by the time I apply the subdivision and smoothing, the smoothing kind of moved that original mesh inward, shrunk it down, but you can see where all he found. And when I originally ran this without the corrections, it was coming from this direction, the rays, and I wasn't finding anything. I was like, wow, that's strange. So having that override in that configuration file, you know, that provided the capability for me not to have to fix the object, if you will. Oh, another important piece I forgot to mention is these game objects that you get from third parties or even your own. You want to go in and make sure on the where you dragged it from, the import itself, the FBX file that you use to drag into your environment, that you set the is read-only button to no, because if it's read-only, you will not be able to apply, and you'll get warning messages in the console telling you that it's the mesh is read-only, and you won't be able to do anything with it. So let me see if I can find the example for you. Bear with me a second. This is in Flooded Grounds, and that's what I couldn't remember earlier. Flooded Grounds is where I got a lot of this material from. Very cool stuff. But like if you go to buildings, if you look over here, and go to the model, where is the read only? Bear with me, it's in here somewhere. There we go, read write enabled. This is it right here. This read write enabled has to be set in order for the procedural C code to have access to the mesh and extract the mesh and do work with it. So all you have to do is, for any of these FBXs that you may have copied into your environments, go back to the original FBX, set this, save it, and it should fix the problem. So that's it. Hope you enjoy it. Hope you can use it. Hope you get some value out of something. If not, oh well, sorry, I wasted some of your time today watching this stupid video. So anyways, thanks for tuning in, and talk to you later.